Hello everyone, this is Lab 2 Lines of Charge. In this lab, the main goal was to become familiar with the idea of charge using household objects like clear tape. Another goal was to understand the concept of the amount of excess charge considering the charge distributed across the tape. In fact, the only difference between this lab and lab 1 was to consider the charge distributed across the tape rather than considering a single point charge. Physical principles. In this lab, we use the Newton's second law, so the acceleration of an object that is produced by a net force is directly proportional to the magnitude of the net force. Then we use the Coulomb's law, so like charges repel and opposite charges attract. Both are proportional to the charge and inversely proportional to the distance between the charges square. Finally, we use the superposition principle, so the net electric field is the sum of all the electric fields. When floating a U tape with another one makes the net Y component of the forces on tape B to be zero. This force is exerted by tape A and it is an electric force. In fact, as you can see in the free body diagram, the magnitude of the electric force and the gravitational force are the same, but they have opposite direction. And here we have to calculate the charge on tape B, and in order to do that, we need to calculate the mass and the distance between these two tapes. Here are some assumptions that I made. So I ignore the air resistance on a moving object and then assume that each U tape had about the same amount of charge evenly distributed among the length of the tape. And here are the measurements of the mass and the distance. Here I set equal the gravitational force and the electric force in order to calculate the charge on tape B, since the net force on tape B was 0. The gravitational force and electric fields were equal, so I could find the charge. It was 1.22049 times 10 to the negative 8 coulomb. Here in the code, first I wrote down the constants, the mass, and the estimated net charge. Then I create functions to calculate the electric field, the gravitational force, and the line of charge. I use this function to create my top tape and bottom tape. And I made these two tapes made of 10 small charges, which I call dq in this code. Here I calculate the electric field created by each of dq's. And eventually I create the arrows of the electric force and the gravitational force. As you can see in the picture, the red spheres are the charges of top B, and the blue spheres are the charges of top A. Then the white arrow is the electric force of top A on tape B, and the yellow arrow is the gravitational force of tape B, and the green arrows are the electric fields or each of the charges of tape A. As you can see, the charge that I got from the computation model is slightly bigger than the charge that I calculate analytically. And if you consider the charge as a single point charge on the tape, we'll have of course a different value, and this will be, and the more realistic value will be considered the charge distributed among the tape, because it's like more realistic than having all the charging in one single point on the tape.